Hi everyone, this is Jeremiah from Frontier Precision, and today we're going to make a mission planning video with the FreeFly Alta X using the Alta Q Ground Control app. The latest version they have is the 1.3.8. This is the desktop app. So once we have that downloaded and installed, we're going to open it up. And if you're not within the mission planning screen, we go and hit this button right here, and now we're within mission planning. So we're going to use the Alta X, and the payload we're going to be using is going to be the Yellow Scan Mapper Plus. So we're going to use some of the settings for the Mapper Plus to plan out our mission. So for our mission, we're going to plan to fly this section right here. And then the first thing we're going to do is we're going to go over here and hit Pattern, and then we're going to hit Survey. The moment we hit that, we're going to see a polygon pop up, and then we're just going to drag and drop these nodes to where we want them to go for our boundaries. So you'll see in a second. Come on. So now if we wanted to add in a node, we'll just hit these little plus buttons, and that adds a node. Just like that. I'll add another one right here, and another one right here. So now that we have our boundaries established, we'll go through and we'll start setting our mission parameters for the sensor that we're flying and for this flight itself. So the first thing we're going to do is we're going to go to the right side where it says Mission Start. And we can actually, if we double click on these, or if you actually select the mission, you can actually move these two. So let's say we're going to fly it from this position right here. That's going to be our planned home. The next thing we're going to want to do is we're going to want to set our flight speed. So for our flight speed, we kind of want to reference this chart right here for the Mapper Plus. So for this mission, let's say we're going to fly at 60 meters at 5 meters a second. So what we need to get out of this is first we need to figure out our swath width for our flight height. So if I'm going to be flying at 60 meters and I go up, we're going to see that our swath width is going to be just over 80 meters. So I'm just going to compromise and say we're going to have a 80 meter swath width. And for us to retain that 50% overlap, we're going to want to divide that 80 meters by 2. So our swath width, or our side distance, is going to end up being 40 meters. In terms of our flight height, or flight speed, we'll go over here again into the point density and speed. So let's say we're going to be flying at the 60 meters, which is right here, and I'm going to be flying at 5 meters a second. If we go up, we'll see right here that our points per square meter density is going to be about 550 flying at 5 meters a second. So I'll be happy with that, and that's what I choose to do. So I'm going to make sure right here, I'm going to set my flight speed to 5 meters a second. Above it, it's our waypoint altitude. So this is the flight height that it's going to get up to before it goes off on its mission. Usually this doesn't matter too much because you're going to take off and fly it manually anyways to do your calibration moves before you start off on the flight. But for this, I usually just leave it at my flight height. In the camera, since it's a Lidar sensor, we're not going to change anything in there. In the end, we're going to want to do return to launch, so it comes home after it finishes its mission. You can leave these as is. And then the next thing we're going to want to do is we're going to go to this right here where it says Survey. When I fly missions, I generally like to fly long ways, but again, it really depends on your situation and the type of mission you're flying. But flying at long ways usually nets you a faster mission. And it's a more efficient way to plan the mission. So again, now what we're going to do is we're going to start setting these settings right here. So our altitude mission, or mission altitude, is going to be 60 meters, which is fine. Trigger distance doesn't really mean anything. because it's not going to be triggering a camera. Since the LiDAR payload is standalone, it'll just be recording the entire time. So you can ignore the trigger distance. But with the spacing, that is something that we have to reference. So this was where we got this in the chart for our swath width. So we said the swath width at 60 meters is going to be around 80 meters. And we're going to divide that by 2 to get our 50%. And we can see right here that is at 40 meters that we want it to be at. But if I wanted to increase it, so this is a 0% overlap, you can see that the flight lines change quite a bit. But I'm going to go back and hit 40 meters. And if we look up here, we can see the total distance that's going to be traveled and the approximate flight time. The next thing we're going to do is we have these turnaround distance right here. This is the amount of distance outside the boundary that you want it to fly. So this is set to 10 meters. Depending on you, I always like to fly a little bit more than I need. I'll usually set this to around 20 just to get these out a little bit further, just to make sure I have everything that I need within the boundary. Here you can also hit rotate entry point, and you can rotate the points of entry of where the mission is. Again, when you do plan these missions, you want to fly to the furthest point first and then start making your way back. So when you start losing your battery power, it's a less of a distance to go from where it is to where you are to land to swap those batteries out. Down here we have hover and capture. We're not going to use that. You can also set it to refly at a 90-degree offset. So if you do that, you can see that it flies a grid, a double grid with the perpendicular lines. But we won't need to do that. It seems like it's a pretty flat terrain with not too many trees or anything in it. Image and turnarounds, again, this doesn't matter. This makes it so when you fly, it will take images in the turnarounds. But again, this is a LiDAR sensor that we're going to be flying for. Again, relative altitude, I usually keep that checked. And then down here for vehicle follows terrain, I will generally always check that too. For this, it will download the DSM maps online and use that for the mission planning too. So down here you can see there's terrain, altitude, and whatnot. After we do that, you can also set a actually it does just return home. So after that, there's really not much else to do besides uploading the data to the drone and taking off and starting the mission. But this is actually planning your mission within Alta Q Ground Control. If you have any questions, feel free to shoot me an email. It's jeremiah@frontierprecision.com, or you can get a hold of us at uas@frontierprecision.com. So hopefully this helps you out in planning your LiDAR area missions with the Yellow Scan Mapper Plus. I'll talk to you guys later.